Good morning, and thank you for joining me here at the Marabou booth at Interop today. We're going to talk a little bit about some of the activities that are going on in wireless test and measurement, some of the changes that the new technologies are bringing on to us. A quick introduction to PCTEL. So I'm Jeff Miller. I'm a Senior Vice President, Sales and Marketing at PCTEL. PCTEL has two businesses, both represented by Marabou here in Japan. Our Connected Solutions division, which does performance-critical antennas for a variety of applications, timing, industrial wireless, broadband, and enterprise Wi-Fi. I run our RF Solutions business, which is responsible for wireless network test and measurement devices and solutions, scanning receivers, software-based applications, and handsets. We're based in the United States, about 500 employees, and publicly traded. If you look at the RF Solutions business, you characterize a business by the customers it keeps. So almost all of our customers are in the wireless network operator space. If you look in the U.S., it's Verizon, AT&T. Here in Japan, Docomo, KDDI are customers of ours. We deal with a lot of the infrastructure players as well, whether that be Extenet, American Tower on the neutral host side of things, service companies like LCC, Tech, Mahindra. So we provide a variety of products into these customers through OEM channels, distributors, and resellers. And we see ourselves as a leader in the scanning receiver space. You'll see a number of the scanning receivers around here on the stand, our blue Ivy Flex scanning receiver. Our antenna business keeps good company in the customer base as well. On the small cell side of things, Huawei and Nokia are large customers of ours for FDD and TDD, LTE small cells. And we do a lot of work in the enterprise Wi-Fi space for large venues with Cisco, Extreme Networks, and Aruba, which is now part of Hewlett-Packard. Specifically to the wireless space, 5G and things that are expanding, if you look, there's a lot of changes going on in wireless these days. 5G gets a lot of the attention with the hype about that. Normally when a new technology comes along, there's a lot of marketing ahead of it before the technologies actually reach the ground. 5G's in that space right now. IoT, Internet of Things, is around everywhere, and there's a lot of technology associated with Internet of Things. In all of these technologies, whether it's 4G technology, 5G technology, or IoT, we believe that scanning receivers play an important part. Scanning receivers are software-defined radios that measure the complete RF environment. So if you look these days, 4G and 5G, or 4G networks are dominantly made up of multi-carrier, multi-technology type of environments. UEs can't measure those environments. Scanning receivers perform high-performance measurements. Our Ivy Flex scanning receiver will measure 13,000 power measurements a second. So it gives a very high-fidelity view of the wireless network. The other thing, difference between scanning receivers and user equipment like handsets is that handsets are directed by the radio access network to use particular channels, look for particular partners for handovers and those sort of things. The scanning receiver is independent and can be used to identify and find configuration errors in the radio access network. Additionally, scanning receiver is the only way to economically benchmark large complex venues. So we've had our services business benchmarking large venues like the Empire State Building. They'll have 38 combinations of operators, bands, and technologies, and the scanning receiver can handle all of those in a single scan, whereas you would have to walk that venue with 38 UEs to get the equivalent type of measurement. So we believe scanning receivers are the right tool for optimizing your wireless networks, whether it's a 4G network, a 5G network, or an IoT network. If you look at one of the things, we talked about the expansion of networks. Large number of carriers, low frequencies, 700 megahertz, 850 megahertz, 1900, 1800 megahertz. The low frequencies are particularly susceptible to interference. The low frequencies tend to propagate farther, and we're seeing more and more issues with interference at the low frequencies, particularly in the U.S. where they've refarmed frequencies, and we're seeing particularly at 450 megahertz in some emerging markets as well. Our C-Wave product is as you'll see back here, back behind the booth, is a tool we've developed, directional antenna, some smart software with our scanning receiver to identify frequencies where the interference is at, We have software that allows you to triangulate to further locate the source of the interference, define it down to a polygon, and then ultimately locate the interferer, whether it's light ballasts, broadband repeaters, jammers, whatever the case may be. And interference is really a problem for customers and the operators. So customers experience poor data quality, pixelation on their video, latency, drop calls, just generally a bad user experience. And of course the operators suffer because they lose customers, and they find a fair amount of churn as their customers turn over, and the cost of acquiring customers is a very large cost that the operators must bear.